All right, so today we're diving into something pretty wild. A battery powered by nuclear waste.
Yeah, it sounds like science fiction, doesn't it?
It really does. But it's actually a real technology. Researchers at Ohio State University are developing it.
It's pretty incredible stuff, and it could have some major implications for energy waste management, even space exploration.
Yeah, and that's what we're going to dig into today.
Yeah.
How does this thing work? What makes it so unique? And why should you care?
Well, it's not every day we see a technology with this kind of potential, addressing so many challenges at once.
Right, like what are we talking about? Solving the nuclear waste problem and creating a new energy source at the same time.
Exactly. It's a pretty ambitious undertaking, but the early results are really promising.
Okay, so we've got this battery running on nuclear waste. I mean, how does that even work?
Well, it's actually pretty clever. It's kind of like solar technology in a way.
Oh, really? How so?
You know how solar panels work, right? They capture sunlight and convert it into electricity. Well, this battery does something similar, but instead of sunlight, it uses gamma radiation emitted from nuclear waste.
So instead of capturing light from the sun, it's capturing light from radiation.
Exactly. They use these things called high-density scintillator crystals.
So that 3 times fast.
Uh-huh, I know, right? But these crystals are key because they basically act like tiny light bulbs when they're hit by gamma rays.
So the radiation hits the crystals give off light, and then what?
Then just like in a solar panel, a photovoltaic cell captures that light and converts it into usable electricity.
Wow, so it's a two-step process, radiation to light to power. That's really cool. But what are these crystals made of? Are we talking about some rare, expensive material?
That's a good question, and it's something researchers are actively exploring right now. They're testing a variety of materials for the scintillator crystals.
And what are they finding?
Well, the good news is that some promising candidates are actually readily available and relatively inexpensive.
Okay, so that's good, because for this technology to be viable, it needs to be scalable and cost-effective.
Exactly, you got it.
Now, when I hear nuclear waste and battery, I kind of picture, a giant battery hooked up to a mountain of nuclear waste.
Uh-huh, yeah. That's a pretty common image, but the reality is quite different.
That's it.
The prototype is actually incredibly small. It's about the size of a sugar cube.
Wow, seriously, a sugar cube.
Yeah, and that's one of the things that makes this so exciting, the potential for miniaturization. Imagine if we can shrink these batteries down even further while maintaining or even increasing their power output.
That would be incredible. So many possibilities.
Yeah, absolutely.
Okay, so we've got a battery the size of a sugar cube running on nuclear waste. It's pretty mind-blowing. But can something that small actually produce enough power to run anything useful?
It really can. Even at this early stage, the prototype generates usable electricity.
Wow, and how much are we talking about here?
Well, the power output depends on the type of radioactive isotope they use. For example, with cesium-137, the battery produced 288 nanowatts.
288 nanowatts. Honestly, that doesn't sound like a whole lot.
You're right. It's not enough to power your house or charge your phone, but
Yeah.
it is more than enough to run small sensors, microchips, or even some low-power medical implants.
Oh, okay, I see. So like pacemakers or things like that.
Exactly. Things that are really difficult or impossible to power with conventional batteries in certain situations.
That makes sense. So we're talking about powering tiny devices, but
Yeah.
still, that's pretty impressive.
It is. And you mentioned isotopes. They also tested the battery with cobalt-60, and the power output jumped significantly to 1.5 microwatts.
Wow, that's a big difference. Why is that?
It all comes down to the energy of the gamma rays emitted by each isotope. Cobalt-60 emits more energetic gamma rays compared to cesium-137.
Oh, so more energy, more power.
Precisely, this means more energy is available for conversion into light, which leads to a greater power output.
That's pretty cool. So you could tailor these batteries for specific applications by choosing the right isotope.
Exactly. That's one of the things researchers are really excited about, the possibility of customizing these batteries for different power needs.
Wow, that's really fascinating.
It is, and we're just scratching the surface here. There's so much more to explore with this technology.
Yeah, I bet, and we'll dive into that right after the break.
That's good.
Okay, so we're talking about tiny batteries potentially running for decades, powered by something we usually consider dangerous waste. It's amazing.
Yeah.
But where could this technology really have an impact? What kind of applications are we looking at?
Yeah, that's the really exciting part. This technology, it's really tailor-made for situations where traditional batteries just don't cut it. Environments that are difficult, dangerous, or just impossible to access for maintenance or replacement.
Okay, I'm intrigued. What kind of environments are we talking about?
Well, the most obvious one is right where the fuel source is, nuclear waste storage facilities.
Ah, okay.
Imagine using this technology to power sensors and monitoring systems within those facilities.
Yeah.
It's a self-sustaining solution. You don't need external power sources or regular battery replacements, which is huge for both safety and efficiency.
Yeah, that makes a lot of sense. You're basically turning the waste problem into a solution for managing the waste itself. It's like closing the loop.
Exactly, and it doesn't stop there.
Oh,
Think
yeah.
about space exploration. We're constantly pushing the boundaries of, where we can send probes and rovers, but power is always a limiting factor.
Right.
Solar panels are great, but they're not always feasible, especially in deep space or on planets with limited sunlight.
So you're saying we could send a probe to, say, Jupiter's moon Europa and have it powered by one of these tiny batteries?
It's definitely a possibility, and think what that would allow us to do, explore the subsurface oceans of Europa looking for signs of life, or delve deep into the caves of Mars searching for evidence of past habitability.
Wow. Missions that were previously limited by power constraints become feasible with this technology.
We're talking about a paradigm shift in space exploration.
It's amazing to think about the places we could go and the things we could discover with this kind of long-lasting, self-sufficient power source. But space isn't the only extreme environment, is it?
You're right, this technology could also be revolutionary for deep sea exploration.
Yeah.
The ocean depths. They're a challenging and unforgiving environment. Traditional batteries have limited lifespans and require frequent recharging or replacement.
Right.
But with a battery powered by nuclear waste, we could deploy underwater drones and sensors that could operate for years, collecting data and exploring areas that are currently inaccessible.
That's incredible. So we've got nuclear waste storage facilities, space exploration, deep sea exploration. It seems like the potential applications are pretty diverse. Are there any other areas where this technology could make a difference?
Oh, the possibilities are vast. We could use these batteries to power remote weather stations in harsh environments, monitor pipelines or infrastructure in difficult-to-reach locations, or even create self-powered sensors for environmental monitoring in disaster areas. The applications are really limited only by our imagination.
It all sounds incredibly promising, but realistically, what are the hurdles that need to be cleared before we see this technology being widely used?
Well, there are definitely challenges ahead. One of the biggest is increasing the power output.
Okay.
Right now, we're talking about microwatts, which is sufficient for small sensors and devices, but for larger applications, we'll need to achieve milliwatts or even watts of power output.
So basically scaling up the power while keeping the size manageable. What else?
Miniaturization is crucial. While a sugar cube-sized battery is impressive for many applications, we'll need to shrink it down further. Imagine integrating these batteries into microchips or medical implants that require significant advancements in materials, science, and battery design.
Yeah, I can imagine. And then there's the whole issue of using nuclear waste, something most people associate with danger. That has to be a challenge as well, right?
Absolutely. Public perception and regulatory approval are critical, even though the batteries themselves don't contain any radioactive material. The fact that they utilize radiation from nuclear waste raises understandable concerns. Researchers are working on robust shielding and containment mechanisms to ensure safety. Additionally, transparent communication and collaboration with regulatory bodies are crucial to address concerns and build public trust.
So it's a balancing act of pushing the technology forward while also ensuring that it's safe and responsible. What are the researchers doing to address these specific challenges? Are there any promising avenues they're exploring?
Well, for boosting power output, researchers are focusing on developing more efficient scintillator materials and photovoltaic cells. They're exploring new crystal structures, nanomaterials, and advanced fabrication techniques to maximize energy conversion.
So finding ways to get more bang for your radioactive buck. And essentially, what about miniaturization? How do you shrink a battery that's already tiny?
It's a tough challenge, but scientists are looking into new ways to structure the battery components, for example. Instead of using bulky traditional electrodes, they are experimenting with thin films and three-dimensional architectures that can increase the surface area and energy density without increasing the overall size.
So it's about being creative and finding innovative solutions. And what about the public perception and regulatory hurdles?
This is where clear communication and transparency are essential innovations. Researchers are actively engaging with regulatory agencies, providing data on the safety mechanisms and long-term performance of the technology. They're also working on developing educational materials to inform the public about the science behind the technology and address any misconceptions or fears.
It seems like there's a lot of work being done on multiple fronts to move this technology from the lab to the real world.
It's a complex challenge, but the potential benefits are enormous. We're talking about a technology that could change the way we think about energy waste management and exploration.
It's incredible to think about how this technology could transform so many different fields.
Hmm.
It makes you wonder what other seemingly impossible innovations are just around the corner. What other scientific breakthroughs are brewing in labs right now that could change the world as we know it.
That's the beauty of science. It's a constant process of discovery and innovation. This breakthrough with nuclear waste-powered batteries is a perfect example of how challenging the status quo and exploring unconventional ideas can lead to remarkable advancements.
It really highlights the power of human ingenuity, doesn't it? We're taking something that's typically viewed as a problem, nuclear waste, and turning it into a potential solution for some of humanity's greatest challenges.
It reminds us that limitations often lie in our own thinking, and that what seems impossible today could become reality tomorrow with persistent research, creative thinking, and a willingness to push the boundaries of what we believe is possible.
This whole conversation has been a fantastic reminder that we should never stop questioning, exploring, and imagining there's always something new to learn and discover. And who knows, maybe one of our listeners will be inspired to make the next big breakthrough.
Absolutely. Every great invention started with someone asking, what if? And then daring to find out. Curiosity and a thirst for knowledge are the driving forces behind progress.
So to everyone listening, keep those minds curious. Stay engaged with the world around you and never lose that sense of wonder. We're living in a time of incredible scientific and technological advancement, and who knows what incredible discoveries await us just beyond the horizon.
And remember, the future is shaped by those who dare to imagine it and then work tirelessly to make it a reality. So keep exploring, keep learning, and keep pushing the boundaries of what's possible.
That's a perfect note to end on. Thanks for joining us on this deep dive into the fascinating world of nuclear waste-powered batteries. It's a technology with the potential to rewrite the rules of energy exploration and even our own limitations. Until next time, stay curious.
Yeah, it really is incredible to think about, how this technology could change so many fields.
It really makes you wonder what other, impossible innovations are out there, right?
Yeah, what else is brewing in labs right now that could, change everything?
Right. That's what's so cool about science, right? It's a process of discovery. You never know what's next, and this battery is a perfect example,
Yeah.
Yeah, like challenging the status quo and looking at things in new ways.
Exactly, and ending up with something remarkable.
And it really highlights the power of human ingenuity, right?
Totally.
We're talking about taking something that's usually a problem, nuclear waste, and turning it into a solution.
Yeah, it's like flipping the script.
Right. And it shows that sometimes the limitations are just, in our own thinking.
Yeah, what seems impossible today could be totally normal tomorrow.
It's a good reminder to never stop, questioning, exploring, and imagining.
Absolutely.
There's always something new to discover. And hey, maybe one of our listeners will make the next big breakthrough.
It could happen. Every great invention starts with someone asking, what if?
Exactly.
Mm.
So to everyone listening, stay curious, stay engaged with the world, and never lose that sense of wonder.
Yeah, the world is full of incredible things.
It really is. And we're living in a time of huge scientific and technological advancements. So who knows what's next?
The future is out there for those who imagine it and then make it happen.
Well said. That's a perfect note to end on. Thanks for joining us on this deep dive into the world of nuclear and waste-powered batteries. It's a technology with huge potential, and we can't wait to see what happens next. Until next time, stay curious.